Hi, this is Miss Nickel, and this is part 2 video for balancing equations with Beads Lab for people who need to retake portions of this lab or do a complete makeup. Whatever you haven't completed in class at this point, you're going to have to do on paper. And so I'm going to be showing you how to do that, and it should also help you understand how we're going to be balancing equations going forward, because we will be doing them on paper for now on. Okay, so in the previous video, I went through the steps for balancing an equation. I'm not going to show you those steps again. They're going to be posted in Google Classroom, but I'm just going to talk through them as I balance this equation number 5. So the first step is going to be to count the atoms in the formulas. That means setting each atom equal to its subscript. So lead is going to be equal to 1. Pb is lead. And for oxygen, hydrogen right now, since the subscripts for the individual atoms are 1, that's what I'm going to put down for now. That's going to be equal to 1, and hydrogen is equal to 1. Now I go to my parentheses subscript. That means both of these have to get multiplied by 2. And so they're actually going to be 2 for each of these. Okay, so moving on. Whenever I don't have a subscript, it's equal to 1. Chlorine is Cl, and that's equal to 1. Of course, water, we've always got 2 hydrogens and 1 oxygen. And then lead, again, here is a 1, and our chlorine is 2 on this side. Now that we've counted all the atoms, set them equal to subscripts, we're going to start comparing reactants and products. We start with the leftmost reactant. In this case, that is lead, and I'm going to compare lead on both sides, and it is the same on both sides for now. So we'll move on to the next thing, but we try to save hydrogen and oxygen for last. So I'm going to skip over to chlorine here and compare my chlorine and the reactants and the products. Here I have 1 chlorine, and here in lead chloride I have 2 chlorines. So I'm going to increase the coefficient on the side where I have less for HCl. That means I'm going to put a coefficient of 2 here, because that'll increase my chlorine to 2 chlorine atoms, which is what I want, but I have to multiply both of the atoms in this formula by 2. So now I have new totals for both of these on this side, and my chlorines are good, they're balanced. We already said the lead is balanced. Now we're taking a look at the hydrogen, because all we have left is hydrogen and oxygen. So I have 2 hydrogens here, but don't forget, I also have 2 hydrogens here. So we have to look at that atom in all of the formulas in the reactants, not just in one. So the total for all of the reactants for hydrogen is going to be 4. And if it helps you, you can write that down here, kind of in the center like that. Okay? So since I have 4 here, I'm going to need 4 over here in my products as well. The only place hydrogen is found in the products is in water. And since I have a subscript of 2 there, I'm going to have to increase my coefficient to 2, because 2 times 2 is 4. And now I will have 4 hydrogens in my product on this side. Okay, so my hydrogens are balanced now. And I'm going to go to the last thing then, which is my oxygen. But wait, I almost forgot to multiply my oxygen by a 2 also. Whenever I increase that coefficient, everything in that formula gets multiplied. So this is going to be equal to 2. So I have 2 oxygens here, and I have 2 oxygens here, right? And no other oxygens anywhere on this side. So it turns out that my oxygens are balanced too. So let's go through it again, one by one. Lead is balanced. Chlorine is balanced. Hydrogen, I'm going to go to this one down here, and here is balanced. And my last thing was oxygen, right? So that here and here is balanced. And that's the best way to keep track of it. So you're done with this reaction. You have 1 molecule of lead hydroxide reacting with 2 molecules of hydrochloric acid to produce 2 molecules of water and 1 molecule of lead chloride. next one that I would like to do with you is one that kind of threw a lot of people off. It's this one right here. We've got propane and it's combustion reaction. So propane is reacting with oxygen to produce carbon dioxide and water. So we're going to list our atoms first. It's a big molecule, like big for what we've been dealing with. So C equals 3 and H equals 8. My oxygen is a diatomic molecule, so that's going to be O is equal to 2. Carbon is 1. Oxygen is 2 here. Water is 2, and oxygen is 1. So now I have counted all my atoms. I'm going to start on the left-hand side. It's fine to start with carbon in a combustion reaction. So I've got 3 carbons here, but only 1 carbon here. So what can I do? I'm going to have to increase my carbon dioxides. I'll put a coefficient here so that I'll end up with 3 carbons on this side. So I'm going to multiply everything in that formula by 3. It's going to be 3 and 3. My new totals are 3 for carbon and 6 for oxygen. So now if I look, I've got my carbons balanced, 3 and 3, right? Now, I said to do oxygen and hydrogen last, but I also said that you want to do single element molecules very last. So we're actually going to do our oxygen last of all, and I'm going to go to hydrogen now, balancing my hydrogen. So if I look at my hydrogen here, I have 8 hydrogens in propane, but only 1 hydrogen here in water. So that means I'm going to have to multiply this by 4, right? If I multiply 2 by 4, I'm going to get 8 on this side. So I'm going to put a coefficient of 4. I'm going to multiply everything in this molecule by 4. So I'm going to end up with 8 hydrogens and 4 oxygens on this side. Now I'm going to look at my totals going between both of the formulas in my product. So carbon and hydrogen only each occur in one formula, but oxygen occurs in 2. So my new total for oxygen on this side is 10. And I'm going to write that down here. Oxygen is equal to 10. Okay, so what else have I changed? My hydrogens are balanced. My carbons are balanced. I can go to my oxygen now. So since I have 10 over here, what can I do to make it 10 over here? If I increase my coefficient to 5, 5 times 2 is 10. So I'm going to multiply that by 5. I'm going to end up with 10 here. So I'm going to go and compare all of my totals one more time. 3 and 3, check. Hydrogen should be 8 and 8, and that's a check. And then my oxygen, I've got 10 here and 10 here. I'm going to check that off. And my equation is balanced. I've got 1 molecule of propane reacting with 5 molecules of oxygen to produce 3 molecules of carbon dioxide and 4 molecules of water. So I hope that this this examples were helpful for you guys to understand how to balance equations on paper. And if you have any feedback for me on that, please do email me and let me know, and I'll provide you with any additional resources that I need to in order to make it possible for you guys to complete this assignment. I'm looking forward to getting back to chemistry class starting soon, and I hope you're all healthy and well.